All right, so we're going to take a look at section 5.4. Okay, your test tomorrow is going to cover sections 5.1, which we reviewed Tuesday, 5.2, which we did yesterday, and what we're doing right now.
Not 5.3?
Nope, not 5.3. Okay, we're going to talk about two special words that are used with inequalities, and they're right in the title: conjunctions and disjunctions. Okay, in English, you might have talked about like a conjunction. Okay, conjunction words. Anybody remember what word we use in English that's a conjunction?
Two words that you put together.
Yeah, it puts two separate things together. What's the word that does that? Like if I said, I want you to go to the store, and I gave you a list of things, or say, I had to make it simple, two things. Two things to pick up. I want you to pick up this, then the word, and. Okay? So that's one thing you want to write down. Conjunction is composed of two sentences connected by the word and. Okay? So for example, I could say something like, today is Thursday and it is cloudy out. Okay? That's two statements. In that case, they're both true. Today is Thursday, it is cloudy out, and I use the word and. Okay? When you have a conjunction, in order for the entire conjunction to be true, both things that you say have to be true. Just like I said before, today is Thursday, yep, true. And it's cloudy outside, yep, that's true. Okay, what if I said we're in the month of January? Is that true?
Yeah.
Yeah, that's true. And what if I added to that, today is Sunday?
No.
No. So if I said to you, is this whole statement true or false? We're in the month of January and it is Sunday.
False.
That's false. Part of it was true. We're in the month of January, but the other part wasn't. So for a conjunction to be true, both parts have to be true. Okay, here's another example. Think about like online, okay, when you log into something. What are the two things you generally have to type in when you log into something? You got to type one thing, and then the thing below it, it's usually like X'd out. You can't see it. Password is one, and your email address or your username. Exactly. For you to log in, which one of them has to be correct? Both. Okay? If you try to log in and the username is wrong, but the password's right, false. It's not going to work. Okay? Let's say your username is wrong, but your password's right. Okay? That's not going to work. You've got to have your username right and the password right. If you want to get into the account you're trying to get into. Okay? Any questions on that? Okay, so that's the idea of a conjunction. Okay.
Guys, I also like Mr. Like when it, in like the little like you have like a little set of quotes on there, quotations, right? It's where it says conjunction. Then there's like a little quote. I want you to put and. I want you to put and right next to it. And then there's more room beyond that in the parentheses. I want you to write. I want you to write overlap. Write the word overlap. O-V-E-R-L-A-P. Once we get to graphing these, all right, that's when that word's going to become really important. So don't worry about too much for it now. When we get to graphing, that word's going to be important, okay? The overlap.
Okay, does anybody have any questions on what a conjunction is? Okay, as Mr. Roy just said, we're going to tie it in with overlap. Okay, kind of a simple thought with that is, let's say I said to you, pick a number bigger than 0 and less than 10. What does that basically mean you have to do? Pick a number that's what? 1 through 10, right? Pick a number between 0 and 10, right? If it's bigger than 0 and less than 10. It's like an overlap, okay? So he's going to show you that when we get into graphing. Okay, next thing we're going to look at is a disjunction. Anybody know what word you use with that? So with a conjunction, we use the word and. How about a disjunction? What if you had two things and you had a choice between them? What word would you use there? Like I could say, yeah, or.
For that.
Yep.
Oh, so these are and or problems?
Yep, it's either going to have an and or an or. Good, yep.
What's the word to put after it?
So the word there is or.
No, but after the quote.
Okay, so a disjunction is composed. Now we're saying sentences. In math, if you say x is larger than 2, that's a sentence. That's a mathematical sentence. X is greater than 2. Or we could also do an English sentence. Okay? I could say something like, let's go back to the examples we used before. Let's say I said we're in the month of January, or it is Thursday. Okay, let's look at both of those. We're in the month of January. Is that right?
Yes.
Okay. It's Thursday. Is that true? Yeah. Both of them are true. Okay? So in that case, we would say what I just told you, we're in the month of January, or it's Thursday. I just said something true to you. That's true. Okay? What if I said we're in the month of February, or it is Saturday? Is either part of that true? No. Both parts are false. We're in the month of February, that's not right. Today is Saturday, that's not right. So the whole statement I just told you is false. Okay? But what if I said this? Okay? What if I said we're in the month of January, or it is Saturday? Is part of that true?
Yeah.
Okay? Well, when you have an or, you don't need both parts to be true. You only need one. So if I said to you again, we're in the month of January, or it's Saturday, well, at least half that's true. So what I told you, that's a true statement. Okay, as an or, you just need at least one part to be true. And that makes the whole thing true. Okay, let's say they gave you an example like at an amusement park, and it said you have to be at least 5 feet tall, or you have to be 16 to go on the ride. You have to be at least 5 feet tall, or you have to be 16 to go on the ride.
So what if you're really short but 16?
So let's just use that. What if, so what does that mean? If you've got to be 5 feet tall, or
Ninja
16.
Over 5 feet tall.
Okay, you could be 5 feet tall.
5 feet or over.
Okay,
Or 16.
or 16. So what if you were 17, but you weren't 5 feet tall? Could you go on the ride?
Yes.
Yes, you could, because you met one of the requirements. It didn't say you had to be 5 feet tall and 16. It said or, so you could have been one or the other. What if you were only 15, but you were a little over 5 feet? Is that okay?
Yeah.
That's fine. Okay, it was an or. One or the other. If one or the other is true, you're good. The whole thing is true. In this case, true meant you could go on the ride. Okay, so any question on that? Conjunction uses and, disjunction uses or. Okay, really, we've been using disjunctions all along, okay, but you didn't know it yet. Okay, how do you pronounce that symbol? It's like 5 words if you say it. Yeah? Go ahead, say one.
Less than one,
Less than,
or greater, no, less than or equal to.
less than, or equal to. Notice what word he said. He said or. Okay? Because he used the word or, that's a disjunction. Less than or equal to. Okay? So you could write that as separate. Okay? If I wanted to write it exactly the way Savon said it separately, I could say x is less than 2, or x equals 2. But we have a special symbol that can combine this and that into the same symbol. We use that. Less than or equal to. Okay? It's a little bit shorter. It combines two things into one. How about that symbol? Who can tell me, how do you pronounce that? Marcus?
Greater than.
Greater than or equal to. So this is also a disjunction. Greater than or equal to. Okay? We don't say greater than and equal to. That wouldn't make sense. Could either be greater than or equal to. Okay? So those symbols are disjunctions. Probably didn't even know it, but now we do.
Where it says example on there, it's circled, that's what you want to write on your notes. The x less than 2 or x is equal to 2.
So example 1a, that's kind of a good problem to lead us in today because we already know how to do it from what we did yesterday. But looking at that symbol, less than or equal to. What is this? Is that a conjunction or a disjunction? This is a disjunction. It's a less than or equal to. Uses the word or. Okay, so now we'll solve that and we'll graph it. Okay, but make sure you copy down that example first, and I think you got that one. All right, so we're going to solve and graph. Okay, what I'll do is, let me just copy it over right here. Okay, so who can tell me my first step? Two things you got to eventually get rid of, an 11 and a negative 3, but you got to do one before the other. Savon?
Subtract 11 from each side.
Good. You're solving this just like you would solve it if that was an equals symbol. In fact, I saw a lot of people that they decide to change that to equals because visually it just helps them to remember. It's like solving an equation. Just be careful though, because if you've got to flip the direction at one point, don't mess that up. Okay, so 11 minus 11, that's gone. What do I have on the left-hand side now, Isaiah?
15.
Sorry, left-hand side.
Negative 3x.
Yep. And then on the right-hand side, he just told us 15. What about my symbol? Dominic, do I flip it? No. I did subtraction. Do I ever flip it when I subtract? No, never. Okay, don't flip it when you do subtraction, ever. All right. Now I'm down to my last step. Okay, who can tell me my last step to get x by itself? Laura? All right, so divide both sides by negative 3. Negative 3 divided by negative 3, that's why we did it, so it cancels out. X. Okay, what's 15 divided by negative 3, Spencer?
Negative 5.
Negative 5. Now the big question, do we flip it? Yes, why do we flip it? We divided by a negative, perfect. Okay, so on a test like you're going to have tomorrow, if it says solve and graph, that's solve. That's step 1. Now you solve. Graphing, that's usually the easier part, especially with this kind of problem. First, we got to decide, is it set up the right way? Yes. Letter, symbol, number. Good. Okay, what's the next decision I have to make? Okay, yeah, I got to number my number line. On the test, that'll already be done for you. Okay, let me number that. So let's go 0, 5. Just go by 5s. Yeah, what kind of circle? What do we call that? A filled-in circle? Yep. Or a closed circle? Right, we're going to shade in all the x's that are greater than or equal to -5. Okay. And that's it, that's the graph. Okay. Any questions on that? Okay, let's try one more, and then Mr. Roy can come up and explain a little bit more about conjunctions and disjunctions. Okay, how about somebody that didn't help me last time? First step here. How about Emma? What do I do on both sides here? Good. She said subtract. Does that mean we flip it?
Oh, no, not
No, you never flip it when you do subtraction. What's 7 take away 1? 6. On the left-hand side, I still have 2y. Okay, last step, and then I'm done solving it. Divide by 2. Divide by 2. 2 divided by 2 cancels out. 6 divided by 2 is 3. Do I flip the sign? No. Since we divided each side by a positive, no need to flip anything. Okay, last part is to graph it. Is it set up the way we want? Letter, symbol, number. Good. Okay, next thing I decide on is what? What kind of circle? How do you know it's filled in? Because it's got the equal. Let me just number my number line first. Now, where are you putting the filled in circle?
On top of the 3.
Yep, right on the 3. Now, which way do we shade? To the, left. Y is less than or equal to 3. All the numbers that are smaller or equal.
Guys, we're shading that 3 because 3 could be included in that solution set. Because it's equal to 3. 3 is equal to 3.
Okay. Any questions on those two? Okay, so Mr. Roy is going to show you some stuff with conjunctions and disjunctions.
Let's get through the disjunction stuff. Let's hand those out. That's when I get through. Once I get through this in the 3 example. Do that. All right, guys. Like we talked about, because when you're gonna get like 3 when you graph these, when you graph your ands and your ors. We're gonna talk about ors, the ors first. So there's gonna be 3 different scenarios you can have when you're graphing an and or an or, as far as the way the lines go when you're graphing. All right. So when I think of ors, I think of when I'm graphing an or, we're greedy. We want to in pretty much every situation, we want to graph everything. We want to make sure on our number line, we want to show that we've graphed everything. We want to graph both lines, and we want to show that. So we're greedy. All right, we're going to graph. All right, so we're greedy, which means we want to graph everything. All right? So, first situation we can have is when we have our lines in our graph, we put our lines in, and they point towards each other. All right? So my first box would be that means in some of this guys, you're gonna have to look at and say, okay, almost like imaginary with like your pencil or your pen, kind of in the air. Say, okay, if I do that line, it's gonna go this way. If I draw that line, it's gonna go this way. Okay, so that's how that's gonna work. So a lot of times you're gonna have to kind of see it in your head a little bit before you do it. All right. So we have lines pointing towards each other. So let's say maybe we had something pointing like a line going this way and a line going that way. So they're crossing each other. So it might look something like this. I got a line going that way, and I got a line going this way. Right? Because when we do these disjunctions, we're going to be graphing 2 inequalities. We're going to be graphing 2 things, 2 lines. Right? We do our graph. If I have 2 lines crossing, they're both going to go on forever. we're doing an or, so we're greedy, which means we're going to shade in that whole number line. If we have a situation like that, when my lines, when I graph, they cross each other. When you figure it out that they're going to cross each other, that's going to cover the whole number line. So we're going to shade the whole number line in. Everything. We're going to shade the whole number line in. That means everything. What do we call that yesterday? If I could pick any number and it works. Anybody remember?
All real numbers.
All real numbers. So I have a situation like this, where I look at it, and we're going to do some examples, and you guys will see. When they cross each other, that means, when I look at it, and lines going either way, right, and they cross each other, that's going to be all real numbers. So, remember, in an or, we're greedy, right? They cross each other. We want to graph everything. All real numbers. That's one situation you can have, where they cross each other, right? Next, we can have when we do our lines, or when we figure them out, and they're going to go in the same direction. So I figure it out, and I know my lines are going to go in the same direction. So let's say I had a line like this. I had something that looked like this. I had maybe an open circle here, and then maybe like a closed circle going this way. All right? When I have a situation like that, when they're both going in the same direction, I want to graph the longer line. All right? I want the longer line on my graph. Right? So I'm going to graph the long line. Remember, I'm greedy. I want to graph everything. Right? So when I do it, I wouldn't graph both these lines. You're going to see in a second how it's going to work. I wouldn't graph both these lines. I would only graph the longer one. That would be my answer. Because whatever number it was, that's anything from here, let's say this is 3, anything from 3 forever would work for that solution set. Right? So we're greedy. We want everything. Then the last one we got, last situation, when we look at it, and our lines are going to go in opposite directions. So let's say we had something like this, going that way, something here, going this way. In that situation, I'm just going to graph in that situation, I would graph both lines. Right? In that situation, I'm going to graph. Remember, I'm greedy. I want to graph both lines. Mr. Hager? Yeah. Good? Okay. All right. I'm going to graph both lines in that situation. I'm greedy. I want to graph everything. All right? Now I'm going to go down. So you guys have this example on your sheet. All right? This is example 2A. So before I start going on and graphing and stuff like that, look at it first. Think about it. Kind of plan it out before you start graphing. Or if you have pencil, if you want to do it in pencil first, that's fine. But think it out, right? So, okay. So I'm doing an or here. So x is greater than or equal to 5, right? So I'd have a closed circle at 5 going this way, right? Closed circle at 5 going this way. And then x, what does this say, guys? X is, so what would I do? Open circle where? At 1, going which way? To the left, right? Right, to the left. So I'm going to have something that looks like this. I got a closed circle here. I'm going that way. I got a open circle here, and I'm going that way. I'm fine, right? Which one do I have up here? This one, 1, 2, or 3? Which situation do I have, Savon? The third one, right? I got the lines pointing in opposite directions. So if I had a situation like this, that's what my graph would look like. In that situation, I'm okay to graph both lines because they're going in opposite directions, it's a or statement, or it's a disjunction, that's the way I would graph it. All right, let's look at, everybody have that? Let's go. Okay. So, first one, Ryan, what would I do for the first part of that question?
Take -1, do an open circle.
Open circle where?
-1.
Open circle, again, we're just planning it out right now. We're not graphing yet, we're just planning it out. Open circle at 1, and what direction?
Right.
This way. So I got an open circle going this way. All right? And then, what's that next one say, Brian?
4.
How would I read that?
R is less than
No. R is,
equal.
no. If it's eating it, it's what? Greater than, right? So R is greater than 4. What would I do to graph that?
Put a circle on 4.
What kind?
Open.
Open at 4, going this way. So I got to open at -1, going this way. I got to open at -4, going this way. If I go back up, so they're both going in the same direction, right? They're both lines going in the same direction. Victoria, what situation do I have there? The first box, the second box, or the third box?
The second
Second box. So what should I do?
one.
Let's go back down, graph the longer one. Which one's going to be longer? R is greater than 1, -1, or R is greater than 4? The -1. So I'm going to put my open circle. Like, who told me? Was that you, Ryan, that told me to graph it that way? I just want to give you credit. Ryan said put an open circle at -1 and graph that way. It's a or. I'm greedy. I want to graph everything. That's why I'm doing it that way. It's an or. I want to graph everything. I'm greedy. Both going the same way. Which line do I graph? Brian. Brian. They're both going the same way. Which one do I graph? What's it say on your sheet? They're both going in the same direction. Which line do I want to graph? The longer one, right? This one's longer. R is greater than 4 is only going to here. I want to graph everything. I want to include both things. Right now on the last example, guys. Now this one, what? Now, I'm on the last one. Now this one's a little bit different than the first two. How come, Dominic?
If you have extra numbers here.
Yeah, I get the other one. The first two, they were just given to me, like boom, all set, graph it, done. These ones, not so much. How come? I gotta do, yes, exactly. I gotta do a little math. I gotta solve, right? So Emma, I'm looking at this, like Mr. Hager calls it, this first sentence. What would I do? Add 5 to both sides, right? Add 5, add 5. What would I bring down? 2x. What do we get here, Emma? 4. Last step, Emma? 5/2. Always divide by the number with the variable, and that would give me x. X is less than 2. So in this one, I'm going to bring my or down. So I get x is less than 2 or. Wyatt, on the other side, for sentence number 2, what am I going to do? -8. Where else am I going to -8? From the 29. Gives me what, Wyatt?
3x
Yeah?
less than.
Greater than?
21.
Last step, Wyatt?
Divide by 3.
Divide by 3, which will give me?
X greater than 7.
All right, now comes that planning part. All right, now comes the planning part. So, Sam Mans, if I was going to graph x, what does this say?
X is less than 2.
X is less than 2. How would I do that?
You put an open circle.
Yeah, and then what?
Then you go to the end.
go to the left. So I got this going this way, that going that way, okay. Then I got this, right? I got this, right? Katie, I got this. I got X. What does this say? So I got the 2 circle going this way. What about this? What would that look like? Going this way, right? So I got this, and I got... Is that okay? That's a situation when they're both pointing in opposite directions. It's okay to grab both. All right? You're going to see when we get into the ands, it's going to be a little bit different. All right, when we get into the ands. Mr. Hager?
Do we have one of the,
I didn't get one in there.
case?
I didn't get one in there. I'm sorry.
do you want to do one?
You can.
Could you like maybe X is greater than 0? Just to show them that.
X is greater than 0, okay?
Or
Or
X is less than 3. Okay, so we're going to show you guys an example of that third case. We didn't have one, but we will in a second.
all right. So again, situation where math's already done for us. There's no math involved. Travis, if I'm going to graph this, what's this say?
It just says that X is greater than 0.
That's all I'm looking for, man. I'm trying to bubble in your mind. X is greater than 0. Perfect. So X is greater than 0. How would I graph that, Travis?
You would put a unfilled circle above 0
Yeah.
and draw a line pointing towards 0.
This way, right? Open circle here, going this way. Open here, going this way. All right? And then I got Eli. So I got an open circle at 0, going this way, right? Now I want to do this. What does this say, Eli? So how do I graph that? This. So I got this going this way, that going that way. What's that situation mean? They're going to cross each other, right? What do we put in our notes? What do we say when they cross each other? And it's an or. Huh? All real, right? It's all real. So what am I going to do? How do I show that? Shade in the whole number line. That's an all real number situation. When they cross each other, it's an or statement, all real numbers. I know it's tough. And again, some of you guys may be better off doing your graph with a pencil first.
I don't even have to.
Huh?
Never mind. Never mind.
You good now? All right, so some of you guys, when we do these, might be better off doing it with a pencil first. That way you can graph both, see what kind it is, erase, and then do your actual graph. Tomorrow, if you need it, we'll have extra number lines ready to go. If you maybe want to graph it a couple times and figure it out, that's fine too. But when we're looking, if it's an or statement, something like that, we're not looking for this. We're not looking for that. We're just looking for all real numbers. All right? So like I said, sometimes you have to plan it out. Okay? Good with this? Everybody's good with this? I can move on? Okay. Now we're going to get into and situations. All right? Now these in the ands, like the ors, they're greedy. They want to take it all. They want to show you everything. Right? They want that, and they want that money. They want to show you it all.
They go dig.
These people, the ands, they're snobby. Like, oh, I really don't like that. I'm better than you. And the one's gonna be. All right? So our ands, they're snobby. There's only certain situations that you're gonna graph. These conjunctions, they only want it to be a certain, they only have it a certain way. All right? So they're snobby. All right? This is a situation where we're looking at the overlap. We're going to look at where the lines we graph, where they cross. All right? Now, first, when we did the disjunctions, first thing we talked about was when they were pointing towards each other. All right, so when they're pointing towards each other. So maybe we got something like, something here, going this way, and maybe another closed one here, going that way. They're snobby, okay? When I get a situation like this, I'm just gonna box it out for right now. We're gonna show you one like this in a second. All I wanna graph is the overlap. So I'm only gonna graph between here and here. There'll be like a closed dot here, and a closed dot there, and that's what I wanna graph. I only wanna graph where they overlap. It's an and, it's snobby. All right, it's only a certain situation, so I'm gonna graph. I'm going to graph the overlap only. Again, like we did with the ors. We got to kind of plan it out first. We got to kind of see it, and then we can graph it. All right. So when the lines are going, yeah, when they're going, yeah, this one, yeah, like that. I'm just going to screw that up. When they overlap, you'll see it in a second, guys. Don't panic about it. But when they overlap, when the arrows are pointing towards each other, I screwed that up again. I did.
Yeah, Mr. Roy, I think you had.
I had it right the first time, mistake. I should have trusted myself.
If you just do undo, it'll put it all back.
So
So if you copied it down the first time, just leave what you have.
they're pointing to, this one's going this way, they're going towards each other. Right, they're kind of like colliding. I only want to graph where they overlap. Then I got them going in the same direction. All right, so I got maybe something that looks like one going something like that, something like this. When I did my ors, and we had a situation like that when both lines were pointing in the same direction, did the longer. So Kayla, based on that, when we're doing the ands, what do you think we're going to graph? Graph the shorter. I would only graph this one. And you're going to see an example like that. Going to graph that shorter line, the one that's shorter. All right? And then what's the last situation we have, guys? When they're doing what? We have them going towards each other. We have them both going in the same direction. What's the other one we could have? When they go opposite. Thank you, Chelsea. We got to go opposite directions. Let's say I got closed dot here, going this way, open dot there, going that way. Now, when we did that for ors, what was the answer? Huh? Graph both. I'm going to graph both, right? It was fine to do that. When I have a situation like this, all right, it's going to be, when it's an and, there's no overlap, right? We're looking for the overlap. If they're both going in opposite directions, there's no way for those lines to overlap. So that's why there's no solution. All right? So we have, like we talked about yesterday, we have an all real number situation when it's an or and they cross. And we have a no solution and an and when they go in opposite directions. All right? I know it's kind of hard. I just want to get you guys thinking about that. I know it's hard to kind of like, I'm not really sure. But when we do the examples, just like we do with the ors, I think it helps the guys to understand a little bit better. So don't start freaking out on me yet. Stick with me. All right? And again, there's not going to be a ton of these on the test tomorrow, guys, but there will be a few. All right? So let's look at, again, this one. Math's already done for us. Nothing we have to worry about. It's already done. You don't have to move anything around. It's all set. So, Justin, how would tell me what this says, and tell me how I would graph it.
X is less than 3.
Sure. If it's eating, it means what? Greater than, right? And what's that line underneath mean, Justin? It's half. That's half of a what? Half of an equal sign, isn't it? So when I have that half of an equal sign, it also means equal to. So let's try it again.
X is greater than 3.
X is greater than or equal to 3. How would I graph that, Justin? So go to 3. Now, it's very important. What kind of circle? Open or closed? Closed, right? That line underneath is kind of like you're hitting, like you better make sure you fill it in. Kind of like your last minute, like, hey, make sure you fill that in. All right, make sure you fill that circle in. So I'm going to have a closed dot at 3. Which way am I going? Which way am I going, Justin?
To the right.
Going to the right. So I got this way. This way. All right? And then I got Isaiah. How would I graph this? What does that say, first of all?
X less than 8.
Okay, so what would I do?
You put a closed circle above the 8.
Careful.
Open.
Good job, man.
Open circle.
Open, going this way, right? So I got a closed going this way. I got an open going this way. What should I graph? They're, say it, Kayla. The points where they overlap, right? So I'm going to do a open circle at 3, like Justin told me. I'm sorry, closed. Justin didn't tell me that. Mr. Ordis made that up. We're going to do a closed circle at 3 and an open at 8, like Isaiah told me. I'm not lying anymore. Now, they're going opposite. They're going to go, this one's going to go, because the arrowhead's telling me, giving my direction, go that way. This one's telling me to go that way. They're overlapping, right? We're only going to graph what? Where they overlap. Just the area where they overlap. Because that would go this way, this would go this way. I'm snobby. I only want to graph where they overlap. Right? So that's why sometimes, guys, you got to plan it out before. And if you need like a scrap piece, or we'll have, like I said, we'll have extra number lines tomorrow. If you need those to kind of figure it out before you put it on your final answer, we can have those available. But like I do, I kind of plan it in my head. Justin?
Are we going to go with the homework?
Yeah, we are going to go with the homework. Yes. All right. So that's that. Okay. Good with that. That's an overlap situation. Now I'm on to this. Oops. Back up a little bit. All right. So now again, solve and graph. All right. Sam, S. What am I going to do first for this one? What am I going to do first for sentence 1? What do you think you do? Anytime we have an equation, inequality, what's our goal? To get it by itself. So what would be your first step be? I see you doing. I think it's in there. Go ahead, tell me. Tell me what you're thinking. You're thinking, Mr. Lloyd, leave me the hell alone. I want to be done, right? You can do it. What do you think? How do I get X by itself? Don't tell me. 3X? No, I'm only don't worry about this. We're only doing this one. How do I get X by itself? Hold on. Give her a second, guys. Huh? 5. What am I going to do with the 5? Nice. What else am I going to take away from, Sam? Nice. I told you could do it. What am I left with? On this side. 1, right? What does that, Sam? One last thing. I promise I'll leave you alone for the rest of the day. What does that say? Woo! X is greater than 1. Thank you, Sam. I won't bother you anymore. All right. Next side. Laura, can you help me out on this side? Subtract 5 anywhere else? Awesome, thank you. That gives me what, Laura?
Cancel out the
Anything else?
3x.
All right, so I got, and this is an and statement, right? And X is, what's that say again, Sam? I lied, I'm gonna bother you one more time. What's it say again? X is greater than 1. So, Chelsea, how would I graph that? Good, that's a good joke. I like that. What do I need to do to be able to graph it?
Define where you can put it.
Yeah, so where do I put it? I'm only doing this right now. So where am I going to stop? Okay, what kind of a circle? Open, going what way? Open to the right, okay. And then, Savon, to do this, to graph this. To graph X is greater than 5, what do I do?
No, you do.
Help me out, man. How do I graph this?
Oh, come on. Open circle to the right.
Open circle where? And then going to the right. So I got one going, I got from the open circle at the 1, going this way. Open circle at the 5, going this way. They're both going in the same direction, correct? Say it, Savon. Graph the shorter line, which would be open circle here, going that way. I want to graph the shorter line in that situation. I'm greedy. All right? One more thing. We got one more, then we're done for this part.
Then can I go to sleep?
No.
Say this one.
Last one. Kayla, go ahead. No solution, right? So I'm going to get X. I got X is less than or equal to -2. So that's a closed going this way. And then I got an X is greater than 3. That's an open going this way. Make sure you write no solution. It's not an or. It's not okay to do that, okay? If they're going in opposite directions, that's no solution if it's an and. Okay? We'll do that last part right now. Mr. Hager's going to start going over that.
All right, so last part. When you write something as an and, okay, the last 3 problems Mr. Roy did, there's a way we can take, and instead of writing 2 separate things like that, we can combine them. Okay, we can take and combine it into one shorter statement. Like that. Okay? And we're going to show you how you do that.
You wrote the one
That looks ugly.
Yep, no, everything there is good. That is correct. Okay, so we're going to show you how we took 2 separate things and combined it into a single statement.
Wait,
Why did you go from?
We're going to show you. I haven't shown you yet.
Guys, wait. When we talk, all the problems we've done, they've all had 3 things in them, right? What's one of those things?
numbers.
Variable, right? We usually want that the first thing on the left, right? After the variable, we want the what?
Numbers.
Not yet. Sign, then what?
Numbers.
Variable, sign, number. So when we're doing something like that, when there's no and or given, we want to make sure we're going to break it down. We want a variable, we want an inequality sign, a different one, and then we want a number in both of them. The biggest thing is you have to make sure that you can't use the same inequality sign in both. You want to use the 2 different ones. Mr. Hager's going to show you how to do that.
All right, so sometimes you've got 2 separate statements and you're going to combine them. What's going to be more helpful for you guys on the test is I'm going to give you a problem like this, and I want you to split it back apart into what it was originally, into the 2. Okay, so I'm going to show you how those 2 statements are really hidden in here. Look at what I just put the box around. Did anybody see where that is up above? Yeah.
Why is there's 2
Well, they flipped it.
X's in that.
Where is that up above?
It's on the top one, but
Yeah, the top one. Does everyone agree, though, that what's in the 2 boxes, they are exactly the same thing?
All Mr. Hager did was just flip the order, right? We've done that before.
Yeah. So we've talked before, if you write something like x is larger than 2 or 2 is less than x, there's no difference between the 2 things I just wrote there. Okay? Pointing at the 2, pointing at the 2. As long as it's pointing at the same number that it started out at, that's fine. Okay? Now, look at this part. Look what's in the red box. Did anybody see where that is?
It's a 4.
Where is it though?
At the end.
Up above. You see where it came from?
Oh, left, problem.
Right here. Okay? So you can kind of see where those two things are all kind of smushed together. Okay? But we're going to show you how you separate
Is
it.
there anything more written on that page?
Nope, but I'm going to rewrite it.
Okay.
How do you do?
Oh, never mind, it is.
I need all the steps though.
So guys, if there's no or and given, like in that one, it doesn't tell you if there's an and or an or.
Is that spelled right, or because it says if there's is?
Yeah, I screwed up. It should be if there is. It should be there is. There should be no apostrophe.
Theirs is.
If there, yeah, it's not if theirs is. It's if there is.
I'm gonna put theirs is.
Mr. Ward needs to go back and work on his English a little bit, I guess. If there is no or and, there's no or and given, it's not actually written there, like the other ones we've done. It's an and statement, it's a conjunction. You need to make it a conjunction. You would take the two problems that you broke down, make it an and you would graph it like an and. Okay?
Okay, there's no way to shorten a disjunction. Okay, so you might be wondering, well, is there another way we can write those? No. If it's a disjunction, what word will you always see?
Or.
Or. If it's a conjunction, it could be written this way. Okay, that's the short way. Could also be written the long way. Okay, if it's written the long way, you'll see the word and. Okay, if it's written the short way, you won't.
And how are you going to know, guys, if you're just given like Mr. Hager what he boxed out up there, right? How would you know that's a conjunction? How is that different from the inequalities we did earlier in the week? Anybody know? Anyone want to take a shot at it?
How's it different?
How's it different?
Oh, the word.
There is no and or
But the ones we saw yesterday and the day before vacation, they only had one inequality sign. This one has two. So if we have two inequality signs and there's no and or written, you need to make it an and. You need to make it a conjunction.
Okay, so before we look at the next example, I want to write one and see if you guys can tell me what the two inequalities are. So just look at that. Okay, can anybody tell me where I could put one of my boxes? I want you to try to identify the two separate inequalities here. Yep.
2 in the less than,
Yep.
and the 8 in the greater than, I think. Oh,
No.
no. Oh, well, 2 is. Oh, yeah. 2 is less than x.
Good. Stop there. 2 is less than x.
Stop, say, Bob.
Okay? So what I could do is if I wanted to split it, put that there for now. Okay? Who can tell me the other one? Yeah? X is less than 8. Good. Now what word is hidden there but you don't see it? And. Okay. So it's just an extra one. What you have up above and what we have down below are exactly the same thing. What's the only thing we normally like to do with this? Okay. Well, this one I think is fine. And is fine. So what would that become if we flip it?
X greater than 2.
Good.
Remember, always want the variable first. Always want the variable first on the left. There you go.
Okay. So let's look at this one. All right, we're going to solve it, and we're going to graph it. First step to solving it is to take and split it back apart into two statements connected with the word and. Okay, who can give me one of my statements? Just give me the one that's on the left. Yeah, Savon.
-3 is less than?
That's a less than.
Less than 2x. Or 2. What is it? 2?
The part that's in the middle goes with both. The whole thing that's in the middle. What's in the middle there?
The x
There's an x. What else is in the middle?
plus 5.
A +5. What else is in the middle? 2.
Let's do it.
That whole thing is in the middle.
Okay.
Okay? So that whole thing, that's
Oh, it's
1.
From sign to sign.
From that sign all the way right up, stop at that other sign. You got
That's
that?
a good way to think of it, actually. It's actually, you're going from sign to sign.
Okay, who can give me my other one? The whole thing. Yep.
X plus 5 is less than 9.
Okay, what else is in the middle? You lost something.
2x
2x. Keep going.
plus 5
Plus 5. Keep going.
less than equal to 9.
Good. Less than or equal to 9. Perfect. Now, once you take and you split it apart, just like we did, now it's like the problems Mr. Roy just went over. Okay? Let's start with this. What's my first step? How would I put that 5 on the other side? Subtract it. And subtract it. Okay, that's going to leave me with 2x. How about my sign? Does it flip when you do subtraction?
No.
Nope. What's negative 3 take away 5? Negative 8. Okay, last step. How do I get rid of that 2? Divide by 2. What happens when you do 2 divided by 2? Cancels. X, you divided by a positive 2. Do you flip it?
No,
Nope. What's negative 8 divided by 2?
Negative 4.
Negative 4. And how did we say we normally like to write this? Is it in the way we like?
No.
No. I want variable, symbol, number. What way is the symbol going to point? What was it pointing at originally? Okay, there's our first part. And. Okay. Second part. Who can tell me my first step here? Subtract the 5. Notice your first step on the other one. Subtract the 5. The steps are going to be the same. Exact same steps again. Minus 5. Minus 5. Okay, what's 9 minus 5?
4.
4. Do you flip the sign when you subtract? No. What's my next step?
Divide by 2x.
What did we do over here? By 2. Divide by 2. What happens to the 2's? Do you flip the sign?
No.
So we get x is less than or equal to 2. Now figure out which of the 3 cases that is. Start with this one. What kind of circle? Open. Open pointing which way? Open pointing to the right. Good. What kind of circle is this one? Closed pointing to the left. What case is that?
It's the first one.
That's where the 2 things do what?
Cross.
They cross over. Okay.
That's not a crossover.
Open circle on 4. Isaiah, what kind of circle on 2?
It's yeah, closed.
Closed. And since they're pointing at each other, you're graphing the overlap.
Yes.
That's your graph right there. Some people do the graph on the number line. If you do, that's okay. If you do it below it, that's okay too. All right. So, Mr. Roy and I are going to pass out your homework. Okay, and your homework tonight is going to be a study guide for the test tomorrow.